Hi, my name is Haley, and today I'm going to be showing you how to connect your VitalsBridge FM to a GE fetal monitoring system. The connections that I show you how to make in this video can also be used to help you connect your VitalsBridge FM to most fetal monitoring systems, as the connections are very similar. Before starting this video, I downloaded the VitalsBridge connector software from vitalsbridge.com/downloads, and I installed it on my computer. I also connected my VitalsBridge to my computer. Connections between a VitalsBridge and a computer can be made using a USB cable, which is plugged in here and into a USB port on your computer, via an Ethernet cable, which is plugged in here on the VitalsBridge and to the Ethernet port on your computer, or via Bluetooth, which is configured with your computer the same way any Bluetooth device would be configured. If you would like to control the VitalsBridge using an Android mobile device or tablet, you can also do that. Download the VitalsBridge connector app from the Google Play Store and connect your VitalsBridge to your electronic device using Bluetooth, the same way you would connect any Bluetooth device. Once your VitalsBridge has been connected to your electronic device and you have the VitalsBridge connector software or app up and running, you should be in this connection tab here. In the connection tab, you'll see any VitalsBridges that have been successfully connected to your device and that have been turned on. Select the VitalsBridge you would like to control and hit connect. Once you've successfully connected your VitalsBridge to your software, navigate to the manual tab so that you can see the different vital signs being supplied to the VitalsBridge from the connection software. It's important to have the software running when you make the connections between the VitalsBridge and your patient monitor so that you can verify that everything is working and that the connections you've made have been made properly. Before beginning, you're also going to need to connect a compressed air source to your VitalsBridge. I'm going to be using the VitalsBridge carbon dioxide canister. The VitalsBridge carbon dioxide canister consists of a cartridge of carbon dioxide and a pressure regulator. Connect the two pieces by following the instructions, which can be downloaded from vitalsbridge.com/downloads. Once you have the VitalsBridge cartridge connected to the pressure regulator, snap it into place on the side of your VitalsBridge, and take the blue hose that's connected to your pressure regulator and connect it to the VitalsBridge where it says CO2 in. This port can also be used to connect any wall source of compressed air or carbon dioxide, but make sure you talk with your facilities manager before connecting so that you know that everything is at the proper pressure. Once you have the tube connected, turn on your pressure regulator so that it is providing a concentration of carbon dioxide between the pressures of 15 and 20 psi. Now that you have your compressed air configured, we're ready to begin connecting to our patient monitor. Before we can connect anything directly to our patient monitor, we need to connect our VitalsBridge FM adapter to our VitalsBridge FM. This is done by using this cable, which was included with your VitalsBridge FM. Take one end of the cable and connect the blue fitting to the port on your VitalsBridge that says UA. Then on that same end of the cable, connect the red fitting to the port that says FHR on your VitalsBridge. Once the two fittings are securely in place, take the other end of the cable and connect the blue fitting to the port that says UA and connect the red fitting to the port that says FHR. Now that we have the VitalsBridge adapter connected securely to our VitalsBridge FM, we're ready to begin making the connections to the patient monitor. The VitalsBridge FM adapter simulates contractions and fetal heart rate. To be able to measure both of these things, you're going to need the ultrasound probe and the TOCO probe that were included with your patient monitor. The ultrasound probe looks something like this. You've got one end that plugs into the patient monitor, and on the other, you've got a circular probe that has a smooth plastic surface on one side. Your TOCO probe should look something like this. You've got one end that connects to the patient monitor and one end that has a rubbery side. Your TOCO probe may also include a small button on the rubbery side of the probe that looks like this. We're going to connect the TOCO probe first. Take the end that connects to the patient monitor and plug it in where it says UA. Next, take the rubber end and the probe end and put the rubber flush against the adapter box underneath the blue ribbon cable. If you pull aside the blue ribbon cable, you'll see an apparatus here. If your probe did have the button, it would go in this hole. Since mine doesn't have a button, I'm just going to center the rubber portion of my probe on the protruding portion of this apparatus. Because my probe also has a pin coming out of the surface, I'm going to put that pin inside one of these holes on the ribbon cable. Now that the TOCO probe is in place, we need to secure it. The TOCO probe is secured using the Velcro strap, which came included with my VitalsBridge. You're going to place the Velcro strap around the adapter box, slide one end into the clip, and then pull the strap tight so that the TOCO probe doesn't move during simulation. Once your TOCO probe has been correctly placed on your adapter box, you should see a TOCO signal appear on your patient monitor. We're next going to connect our ultrasound probe. The ultrasound probe is plugged in to the patient monitor where it says US. Once it's been plugged in, we're going to need to put some ultrasound transmission gel on the smooth plastic side of our probe. You only need a small dot of the transmission gel. Once you have that in place, you're going to slide this probe underneath the pink ribbon cable, and you're going to need to make sure that the ultrasound transmission gel is located directly on top of the black silicone bubble, which you can see on your adapter box. Once the probe has been properly placed, you should begin to hear fetal heart rate beats, and you'll see the fetal heart rate appear on your patient monitor. All right, the next thing that we need to do is we need to calibrate our TOCO signal. You'll notice how the TOCO number is not what we might expect for a TOCO reading. So we'll come here to the configuration tab of our VitalsBridge connector software, and we'll navigate to the little button that says TOCO. When we select the button that says TOCO, any calibrations that we've previously performed will appear in this black box. To perform a new calibration, select the new button and enter the calibration name. Since we're using a GE monitor, I'm going to use the name GE. Once you have the name entered in your calibration, select Submit. Your VitalsBridge is then going to set a reference setting for your contraction activity. It will take just a moment. Wait for the countdown to finish before proceeding. When the countdown finishes, you'll see a little box window on your computer that tells you to set the UA reference value. Push the button on your patient monitor that says UA reference. This will change the TOCO signal on your patient monitor to a base value. When you've referenced out your patient monitor, select OK and then enter the reference value in the box on screen. Our reference value is 10. Once you've done that, push Submit. You're going to hear the VitalsBridge pump starting to go, and you're going to see the TOCO value rise. We'll wait for just a moment, and then when the countdown has finished, we're going to enter the TOCO value on our patient monitor inside the box on screen. Enter the highest TOCO value you see, the highest stable TOCO value you see. The highest one I've seen is 78, so that's what I'm going to enter into my software. And I'm going to select Submit. You're going to keep repeating this process until the calibration curve within the VitalsBridge connection software has developed a good baseline for how much different pressures inside the adapter box will affect the calibration reading. This next one is 104. And if you see the TOCO value level out before the box has appeared on screen, you can skip the countdown by pressing this button. Though I recommend making absolutely certain that you know your TOCO value has leveled out so that you can get a good calibration. For this last level, we'll wait for just a minute for it to level out. And you can see that the TOCO value continues to drop. It looks pretty stable there at 28. So we will put in 28 for this value here. And our calibration is complete. When you finish your calibration, make sure that the selected calibration is the calibration you've just performed, and then navigate back to the manual tab. Your TOCO values should continue to perform nice calibrations. If you notice, however, that your TOCO value in the trough of your contraction signals is higher than the number that you set for your reference value, you can always reset your reference value during the trough of a contraction by pressing the UA reference. But make sure you don't push that button while you're in the middle of a contraction and the numbers are rising or falling. We'll just wait for this contraction to proceed. Coming all the way up to a value of 70, which is what is set in our software. But you'll notice it's going higher because we don't have the correct reference value. When it drops back to the trough, we'll hit that reference button and it should balance everything out. So it's dropping. As the contraction finishes. The last trough I saw was close to 30, so when it reaches down to 30, that's when I'm going to reset that UA reference. It's just about there in the trough. So I'll select the reference button, which will drop the TOCO value down to that 10 that we want it to be at, and then the next contraction should be calibrated with what our connector software has. Since contractions aren't really a perfect science in terms of when you are having a baby or monitoring someone who is going to have a baby, it's totally okay for these signals to not be perfect. In fact, the VitalsBridge has been designed to have a little variation in the signals to better simulate real-world situations. All right, the next thing we're going to connect is our SPO2. The SPO2 measures the oxygen saturation in the mother's blood. The cables that came with your patient monitor should look like this and this. This cable here has a connection that goes directly to the patient monitor and has one end that's going to connect to the SPO2 probe. This is the SPO2 probe. This end plugs into the cable that you will be connecting to your patient monitor, and this end would typically go over a mother's finger. Connect this part of your cable that plugs into the patient monitor where it says SPO2 on your patient monitor. Once that's been plugged in, connect the SPO2 probe to the other end of that same cable. Once it's been connected, snap it into place, and then place the probe on your finger. We do this to make sure that the SPO2 probe is working properly. That way, if there's a problem with our SPO2 readings, we know whether it's coming from the probe or from our VitalsBridge. You'll see how I'm displaying a pulse and an SPO2 concentration rate on the patient monitor, so we know that the probe is working properly. We're next going to pull out our SPO2 oximeter adapter, which was included with our VitalsBridge. It includes this box here and a cable that has two matching ends. Take one end of the cable and plug it into the VitalsBridge where it says SPO2. The port is here on the VitalsBridge. Once you have that plugged in, take the other end of the same cable and plug it into the oximeter adapter box where it says SPO2 port VitalsBridge. When that's been plugged in, take the SPO2 probe you've already verified works on your finger and place it over the white finger in the oximeter adapter box. Once that's been properly connected, give the patient monitor a moment to initialize and you should see an SPO2 reading here. If the SPO2 saturation level is not what you would expect from what you've put into your connector software, that's really easy to fix. Come to the Configuration tab and perform a calibration the same way you performed the calibration on the Toco. The next thing we're going to connect is non-invasive blood pressure. The non-invasive blood pressure cable for your patient monitor looks like this. You have one end that plugs into the patient monitor and another end that has the connection you would make with a blood pressure cuff. Plug in the end that goes into the patient monitor where it says BP. Once that's secure, we can begin connecting the other end to our VitalsBridge. Because not all blood pressure cuffs have the same connections, you're going to need to make an adapter specific to your non-invasive blood pressure cable so that you can connect it to your VitalsBridge. With your VitalsBridge, you should have received a bag that looks like this. It says NIBP fitting kit, or non-invasive blood pressure fitting kit. If you have a 2-tube non-invasive blood pressure cable, you're going to need this Y adapter. If you have a 1-tube, you're going to need this single tube adapter. Once you've pulled out the adapter that matches your non-invasive blood pressure cable, go through each of the fittings included with your non-invasive blood pressure fitting kit and find two that will clip perfectly onto the ends of your non-invasive blood pressure cable. Once you've found two fittings that match, plug them into these two ends of your non-invasive blood pressure fitting adapter. I've already prepared one in advance that's for my particular non-invasive blood pressure cable. My final adapter looked like this. I'm going to take the two ends that I just configured to fit with my non-invasive blood pressure cable, and I'm going to snap them into place. Once they're secure, I'm going to plug the pre-configured end of the adapter into my VitalsBridge where it says NBP. Once that's secure and tight, I can take a non-invasive blood pressure reading on my patient monitor. This is done by pushing the button that says BP start/stop. You're going to hear some vibrational noises from your patient monitor and from your VitalsBridge. This is normal and it means that you're getting a good reading. The reading, when it's finished being taken, will appear here on the non-invasive blood pressure section of your patient monitor. If the reading you get the first time doesn't match well enough with your VitalsBridge connector software, just rerun the reading and you should get something closer to what you have set. On my particular VitalsBridge connector, I have it set to be 120/80, and we have a reading of 119/75, which is perfect, exactly where we want it to be. The last thing that you can connect to your VitalsBridge is an ECG cable. I'm not going to connect one today, but if you would like to connect it, plug the end that plugs into the patient monitor where it says ECG, and then connect the ECG leads to the buttons on the bottom of your VitalsBridge. The ECG leads should be colored or have a small label with 2 letters. Match the ECG lead via color or lettering label to the buttons on the VitalsBridge. For example, you would connect the green lead or the green that said RL to this button here that has a green stripe and the letters RL underneath it. The last thing I'm going to show you how to do today is connect your VitalsBridge to a simulator. In your VitalsBridge connector software, navigate to the Simulation tab. Any simulators you currently have running will appear in this black box. I currently have a virtual simulation running on my laptop. I'm going to select the simulation I want and hit connect. Once I've successfully connected, you'll see a variety of vital signs appear on my screen, as well as what they correspond to. These vital signs are the vital signs the VitalsBridge connector software is receiving from your simulation. But you'll notice how my SPO2 has disappeared. This is an easy fix. Come to your simulation software, and underneath the patient monitor on your screen, you should see a bunch of boxes with vital signs in them. Select the boxes for the vital signs you would like to display, in my case, SPO2. These check boxes tell the simulation software that you do have a VitalsBridge connected and those vital signs should be being displayed. Once you've selected that box, you'll notice that the SPO2 saturation level and the pulse have reappeared. One other thing to note is when using the VitalsBridge FM, if you would like to simulate the fetal heart rate signals and the contraction signals, you're going to need to be using the SimMom Laerdal Leap software. Once you have the simulation connected and you've checkboxed everything that you have connected to your VitalsBridge, you can then control the vital signs directly from the simulation page, and those vital signs will be transmitted through the VitalsBridge and displayed on your patient monitor. I hope this was helpful and that you've learned how to connect your VitalsBridge FM to a fetal monitoring system. Good luck!